In today's lesson, we are looking at surface area of prisms and cylinders. Again, as I told you before when we were going through last chapter, this chapter is going to be a lot of formulas as well that you're just going to have to commit to memory and understand how and when to use them and how to apply them to certain scenarios. So first of all, what is a prism? Just quick review. A prism is a polyhedron with two congruent faces called the bases that lie in parallel planes. Okay, so and we always name the prism based on its bases. So for example, in this particular diagram here to the right, this shape that I'm tracing here in blue is one of the bases, and then this guy down here that I'm also tracing in blue would be the other base, and so those would be called our bases. So we would call this particular figure a pentagonal prism because the bases are pentagons. The lateral faces are the parallelograms that are formed when you connect the two bases. So in other words, this guy here, let's see if I can get this. I'm going to use green actually. So this front face here, this guy I'm outlining in green, that's one face, and then this guy is also another lateral face, and then we have this guy back here, and we also have the one along the side there. So you have your lateral faces, and then you have your lateral edges, which are the segments that connect corresponding vertices of bases. So in other words, that's a lateral edge, that's a lateral edge, lateral edge, lateral edge, lateral edge. So just some terminology that you want to be familiar with. The surface area of a polyhedron is the sum of the areas of all of its faces. So you have your two bases, and then you also have all of the lateral faces that you also find the area of and add them together. Okay. The lateral area is the sum of the areas of the lateral faces. I just said that. And then a net is if you were to take this three-dimensional polyhedron and unfold it, what would it look like unfolded? And so there's just kind of an example there to the right. And we'll talk a little bit more about nets. We won't spend a ton of time emphasizing nets, but we will talk about them briefly just so you understand what they are. Okay, so a right prism is a prism in which each lateral edge is perpendicular to the bases. An oblique prism, they are not perpendicular. Okay, so i.e. you have two diagrams there that kind of show you what we're talking about. In a cylinder, now a cylinder, you can think of it as a prism. The only exception is that it's not a polyhedron because, again, a polyhedron, all the sides are polygons. In a cylinder, your two bases are circles, and then you have, obviously, there's no lateral faces in a cylinder, okay, because it's just it's a round, so there's no figures there. A right cylinder is a cylinder in which the centers of the two circles are perpendicular to each other if you were to connect them. In an oblique cylinder, they would not be perpendicular. Alright, so surface area of a right prism, okay, it's 2b times pH, where capital B is the area of the bases, the capital P is the perimeter of the base, and H is the height. Okay, so 2B plus pH. Alright, that's the only formula we're going to use here. So it says find the surface area of the right prisms in part A here. Again, start with your formula. SA equals 2B plus pH. Now you'll notice you have to do some side work here. Okay. In this particular diagram, because it's a rectangular prism, it doesn't really matter which side you view as your bases. For me, I always, I'll use this bottom guy here and the top guy there as my bases. So now a side note here, capital B then is it's a rectangle, so it's base times height, and the base here would be 5 and the height would be 6. So it's 30. So 2 times 30 plus perimeter would be 5. Let's see here. I'm going to use a different color here. Perimeter would be 5 plus 6. That's 11 plus 5 is 16 plus 6 is 22. So 22. And then the height, right? So I have my two bases marked in red. The height is the distance between those bases, and obviously that 7 there would be the height. And so now I just simplify this. This is 60, and then 22 times 7 is 140, plus 14 is 154. And so the final answer here should be 214, and it's surface area, so it's meters squared since it's areas. Okay. Part B here is a triangular prism. Okay, so this guy and this guy are your two bases. Okay, and again, I know that because your bases will always be the non-parallelogram sides. Okay, now in Part A, you noticed that every single side's a parallelogram. Every single side was a rectangle, so you could have viewed that a few different ways. In this particular problem, Part B, the only way to do this is to consider the triangles your bases. So again, surface area equals 2b plus pH. The bases are your triangles, so you have 2 parentheses 1/2 times the base is 8 times the height is 5 plus the perimeter. Now you know I'm going to have to do a little bit of work here, right? Because in order to find the perimeter of the figure, I need to know all 3 side lengths. I know 2 of them, but in order to find the third side, I have to use the Pythagorean theorem. Okay, so I have 8 squared plus 5 squared, so I have, let's grab my calculator real quick. Alright, so I have, let's see here, I have 25 plus 64 equals 89. The square root of 89 is 9.4. So the hypotenuse here is 9.4, and so that makes the perimeter of my base, I'm running out of room there, I apologize. The perimeter of my base is going to be 13 plus 9.4, which is 22.4. So perimeter 22.4, and then the height again is just the distance between your bases, and that distance there is 12. And so now I just have to simplify this. So I have 2 times half of 8 is 4. 4 times 5 is 20. So I have 2 times 20 plus 22.4 times 12, which is 268.8. That's 40 plus 268.8. And when I add those two together, I'm going to get 308.8. Again, units, feet squared, because it's an area. So again, surface area 2b plus pH. Alright, the surface area of a cylinder is the same idea. The only difference is now we can be a little bit more specific. So for example, it's 2b plus ch, where c is the circumference, right? Circle doesn't have perimeter, we call that circumference. I could rewrite this as 2 pi r squared plus 2 pi r h, if I'd like. And all I did was, instead of capital B, since a cylinder, the basis will always be a circle, we know that B will always be, we'll always use pi r squared, and the circumference will always use 2 pi r. Alright, so it doesn't really matter how you do it either way. So it says find the surface area of the right cylinder. So surface area equals 2 pi r squared plus 2 pi r h. I know my radius is 4, so I have 2 pi 4 plus 2 pi 4, and then the height of the cylinder is 5. And so when I simplify this, I get 8 pi. Alright, why is this not working for me here? There we go. 8 pi plus 2 and 4 makes 8. 8 and 5 makes 40. So your exact answer here would be 48 pi meters squared. Again, you could plug that in and get a decimal either way, but that's the idea. Alright, it says find the surface area of a right cylinder with a height of 9 centimeters and a radius of 6. So you can draw a picture, or you can just know surface area equals 2 pi r squared plus 2 pi r h. So 2 pi, now that I think about this, I think I screwed up on the first problem. Let's go back here and take a look. I did not square my radius in this first part, so that's going to goose things up here a little bit. So I didn't square it here, and so that's going to change my answer, so let's go ahead and fix that. Sorry about that. Better I caught it now than never. Alright, so I have 2 pi, that's going to be 16, plus, I apologize guys, I have no idea why the smart board is not working out right now. See if I can drop this thing and pick it back up and see if... Alright, anyway, plus plus, Alright, let's try this again. 2 pi 16 plus, we already said 2 and 4 makes 8, 8 and 5 makes 40 pi. So this is going to be 32 pi plus 40 pi. So 72 pi meters squared is going to be the surface area of the cylinder. Okay, sorry about that. Good thing we caught that. Some of you were probably wondering, or probably waiting to see me in class and point that out. But so anyway, so 2 pi r squared. The radius is 6, so 6 squared plus 2 pi times 6. And then they told us that the height of the cylinder was 9. So I have 2 pi 36 plus 2 and 6 is 12. 12 and 9 is 108. So I have 72 pi plus 108 pi. 72 and 108 makes 180 pi centimeters squared for the surface area. Alright, example 5 is a good question because it's asking you to find something else. So it says, find the height of the right cylinder shown. Okay, so we know the surface area, so we know as soon as we see surface area, we're thinking SA equals 2 pi r squared plus 2 pi rh. I know surface area is 198.8, and I know that my radius is 2.8, so I have 2 pi 2.8 squared plus 2 pi times 2.8 times h. I gotta get h by itself. So I have 198.8 equals, okay, so this is where a calculator is going to come in handy. Let's see here. I'm going to use 3.14 for pi, so I have 2.8 squared times 3.14 times 2. So I got 49.24. 49.24 plus, over here I have 2.8 times 3.14 times 2. I got 17.58. 17.58 h. So subtract 49.24. So I get, again, let's see here. I get 198.8 minus 49.24. 149.56 equals 17.58 h. Divide both sides by the 17.58. Cancel. And so this is going to tell me that my height is, let's see here, 149.56 divided by 17.58. I get 8.51. And again, don't forget units. The height is 8.51 millimeters. Okay. Example 6. If you are in my honors class, go ahead and take a look at that. If you are in my regular class, you could try it, but we're not going to emphasize examples like that too much. Okay, so now we're going to look at some nets. It says draw a net for a pentagonal prism. Okay, pentagonal prism. So you know your bases are pentagons, and so the way you'll start the net is you're just going to say, okay, I have a pentagon. Let's see here. Alright, that's as good as my pentagon's going to get. Alright, and so then what you'll have is, you know you're going to have your lateral faces. And off of these lateral faces, you're going to have, off of one of them, you're going to have another pentagon. So right here, I'm going to have another pentagon. And that kind of summarizes this section. A lot of stuff, you know, surface area, formulas that you have to know, and then nets. So any questions, as always, bring them to class, and we'll take those first thing.